Hi there, Mr. Sutton here with the IM372 Extra Practice number 3 solutions on special right triangles. This one's a little extra spicy. This has doubled up special right triangles. For this doubled up right triangle, we're trying to find x and y, and we only have this single side over here, 5, that's given. Now the key here is recognizing, in this first triangle anyway, that we can find the y in, that we've got 30 degrees for this other angle. That makes this first triangle at least a 30, 60, 90 triangle, whose sides are going to be in the ratio of s to s root 3 to 2s. So let me go ahead and label that triangle with those sides. S is going to be across from 30 degrees, so down here. So y and s actually correspond. And then s radical 3 is across from 60, that's over here next to the 5. And then 2s is this hypotenuse that it doesn't look like it's going to get used, but we'll put it there anyway. So now to find the value of s, let me find the actual side they gave me. They gave me this 5 here, and again, that corresponds with s radical 3. So s root 3 equals 5 is the equation we can write out of that. And if I solve this, I get the value of s. Let me solve by dividing by radical 3. So s is going to be 5 over root 3, which if we multiply by root 3 over itself, we can simplify this to just 5 root 3 over 3. We're going to have to do it anyway, so might as well get it out of the way now. And then, now that I've got the value of s, I can solve for any other side of the triangle. Now specifically, the only side I care about is this y side here. That's one of the variables I needed to find. It looks like y is equivalent to s. So that means that y equals 5 radical 3 over 3. Great. Now we need to move on and find the value of x in this other triangle. So I'm just going to redraw this original lower triangle here, just considering that piece of it. But one thing I do know is that this side up here, that's this y that we just found, that's 5 radical 3 over 3. So I can use that to help me find the value of x. Now it turns out that this we've got 60 degrees here, so that means there's 30 degrees left here. This is another 30, 60, 90 triangle. So we have the n to n radical 3 to 2n ratio that we had over here with the first 30, 60, 90 triangle. And I'm using n's because I don't want to confuse my n's and my s's. Like my s radical 3 side in this triangle might not be my s radical 3 side in this other triangle. So it's like a clean slate. But now let me label this particular sub-triangle with these 3 expressions. So n is going to be across from 30 degrees over here. N radical 3 is across from 60, so that corresponds with x. And then 2n, the hypotenuse, that's this 5 radical 3 over 3 side that we already know. So since I know this side here is 5 root 3 over 3, and I know that that's equivalent to 2n, let me set those two equal to find the value of n. So to get n, I have to divide both sides by 2 here. So that basically means multiplying by 1/2, which means I'm going to have 5 radical 3 over 6 if I multiply by 1 over 2. So that's my value of n. Now I actually wanted to find the value of x. What is x in terms of n? Well, we wrote right here that x equals n radical 3. So that means that x is going to equal 5 root 3 over 6 times this radical 3. And if we have a radical 3 times a radical 3, that's going to give me a 3 up here. 3 times 5 is going to give me 15 over 6. And then I can reduce that to, let's see, reduce it by 3s, that's going to be 5 over 2. For this double-decker triangle problem, we're trying to find the value of x and y, and all we know is that the hypotenuse of this upper triangle here is 5 radical 2. Well, since I've only got one side of a right triangle, I can't use Pythagorean theorem, but let me try and use special right triangles. If this angle here is 45, 90 minus 45 gives me 45 down here as well. So this upper triangle is a 45, 45, 90 triangle whose sides are in the ratio of s to s radical 2. Let me label the triangle with those sides, and then we can see what corresponds with what here. So these s sides are always across from the 45 sides. So we've got s over here and also over here. And then s root 2 is across from 90, this 90 degrees. So that's going to be this side over here is equivalent to s root 2. And I see that they gave me 5 radical 2 for that side. So that means that s radical 2 equals 5 radical 2. If I divide both of those by radical 2, I get s equals 5. Well, now that I've got s, I can plug that in to find the value of, well, it looks like y is the only thing that was latched onto this triangle. So y is equivalent to that s expression, which means that y equals 5. All right, so we've got y, but x is down in this other triangle. So I'm just going to redraw this lower triangle so I can consider it separately from this top one. But not completely separately, right? Because the y side of this upper triangle is this upper side of the lower triangle. This side up here we actually just found, that is 5. So that'll help us figure out x, because we need at least one side to find another side. Now, just like the upper triangle, this has a missing angle of 45, so this is another 45, 45, 90 triangle, which means the sides have the same ratio as the upper triangle. But I'm not going to write s's again because I don't want to confuse things. So I'm going to do this with n's. So I'm going to say we have an n to n radical 2 ratio. And let me label this with n's now so I can see what's what. The n's are going to be across from the 45s. So we have n over here and over here as well. And that means that my hypotenuse side here is going to be n radical 2. So the only side they gave me was this 5. We know that that is equivalent then to n radical 2. So n radical 2 equals that 5. And then if I divide by radical 2, I've got 5 over root 2 for n. And if we go ahead and simplify that by multiplying by root 2 over 2, root 2 over root 2, that's going to be 5 radical 2 over 2 for the n value. So now that we have n, let's go back and plug that in to find x. It looks like x is actually exactly the same value as n as we labeled it up here. So that means that x is 5 radical 2 over 2. For this double triangle, I'm trying to find the values of x and y, and all I have is this 9 side up here in this top triangle. Well, since I have a right triangle but only one side, I'm probably going to end up using special angles. Let me see if I have a special right triangle up here. Since we've used up 45 degrees and we already had 90, that means there's another 45 over here. So that top triangle is a 45, 45, 90 triangle. And that means that the sides of this top triangle will be in the ratio of s to s radical 2. Let me go ahead and label those sides with these s's. So the two s's here, those always go across from 45 degrees. So we have an s up here and also over here. And then the s radical 2 is always across from the right angle, the 90, so that's down here. That actually corresponds with y. And now, if we solve for s, we can plug that in to find anything we want on that top triangle. Well, it looks like one of those s's is on that 9 side. This means that s equals 9. And that means that y, which is equivalent to s radical 2, y actually equals 9 radical 2. Okay, so I found one of my variables. Now I need to find x. To do that, let me just redraw this lower triangle. And since I already found this side up here, that actually corresponds to this side in that triangle. So let me just write in 9 radical 2 there so that I realize that's actually one of the sides I know. So just like before, I'm going to have to use special right triangles. But this time around, we've got 60 degrees as my non-right angle. So that means the other angle is 30. So 30, 60, 90 is what we're dealing with here. So that means the sides of this particular triangle are in the ratio, and I'm going to use a different letter now. We'll say n to n radical 3 to 2n. And let me label this part of the triangle now. So n is across from 30 degrees this time around, so down here. Doesn't look like that's going to do a whole lot for us on this problem. N radical 3 is across from 60, so that's equivalent to the 9 radical 2 up there. That's going to be interesting. And then 2n's across from our right angle, so that's what x is. So we still need to find n in order to find x. Now it looks like 9 radical 2 and n radical 3 are the same thing. So if we set those equal to each other and solve, to do that I'll have to divide by radical 3. And if I simplify this radical, because we know we're going to have to, I multiply by radical 3 over itself. So that's going to give me 9 radical 6 over 3. And then 9 divided by 3 just gives us 3 next to that radical 6. Now let me go ahead and plug that back in to find the value of x. We saw up here that x is equivalent to 2n. Well, that means x is going to be 2 times 3 radical 6, which means x is going to be 6 radical 6. For this problem, I've got these two right triangles stacked on each other, and I'm trying to find y and x. And I'm probably going to have to find y first because that's part of the triangle that they actually gave me one of the sides in, this 9 side. They only gave me one side, but it is a right triangle, and I do have one of the angles. So let me see if this is one of those special right triangles. If I've used up 45 degrees here, that means I have 45 down here. So this is a 45, 45, 90 triangle, which means the sides are in the ratio of s, s, and s radical 2. The s's correspond with the 45 degree sides. So we have an s down here across from this 45 degree angle, and across from this 45 we have an s on the other side. And that means across from my right angle, the 90 is going to be s radical 2. So that's this 9 side here. Since s radical 2 and 9 are the same side, that means s radical 2 equals 9. So we can use this to solve for the value of s, which would be very helpful if you're trying to find y, because s and y are essentially the same thing. So dividing by radical 2, we have 9 over root 2. And then let me just multiply by root 2 over itself to simplify that. So that ends up being 9 radical 2 over 2. Okay, well we said that y equals s, so that means y is 9 radical 2 over 2, and we have officially solved for one of our variables. But we still got to get x. So to get that, I'm going to have to use this lower triangle, and things are kind of a mess here, so I'm going to redraw this lower triangle over here. And because I already found the value of y, which happens to be the top of this triangle as well as the bottom of the other, it's a shared side. Let me put y up here. So this is 9 radical 2 over 2 that I just found. Now that I've got one side over here and a 45, 45, 90 triangle, I can use that to solve for x. So just like this other 45, 45, 90, I have this ratio here. I'm going to use n's this time around so I don't mix it up with my s's though. So I'm going to write n, and n radical 2. So that means I have an n side across from the 45 degree angle there, and another n side over here. And then this n radical 2 side corresponds with my hypotenuse for this lower triangle. Well, if n radical 2 equals 9 radical 2 over 2, I can divide by radical 2 to solve for the value of n. If I divide by radical 2, that cancels out this radical 2 and this other radical 2, so that means n just equals 9 over 2. Well, now x is the same as n. That's how we labeled this triangle. So if x equals n, that means that x equals 9 over 2. On this problem, I'm trying to find the values of x and y in these double right triangles. Let me start by finding y, because I at least have this side here in this triangle that's 10. Since I only have one side in a right triangle, I'm probably going to have to use special right triangles. If I've got 60 degrees here, that means this other angle in the top is 30. So that means I've actually got a 30, 60, 90 triangle whose sides are going to be in the ratio of s to s root 3 to 2s. Let me label that left triangle with those sides. So s is going to be across from 30 degrees down here. Across from 60 we have s root 3, and across from the right angle, 90 here, we have 2s. The only side they gave us was this 10 side, and that's equivalent to 2s. So I can write 2s equals 10, which means, dividing by 2 here, that s equals 5. Well, that's going to help me find y, because we said that y is equivalent to s radical 3. So that means that y is going to equal 5 radical 3. And at this point, I'm going to redraw my second triangle so that I can focus on finding x. But before I go any further here, this left side of this right triangle is shared with this first right triangle. That's actually the side we just found, the y side. That's 5 radical 3, so let me write that in there. And now on this triangle, I noticed that just like the other one, I've got 60 degrees in a right angle. So we've got 30 up here, and this is again a 30, 60, 90 triangle over here. So that means the ratio is going to be the same. Just to make things a little less confusing, I'm going to use n's instead of s's so that they don't get mixed up. So I'll write n radical 3, and 2n. And now let me label this triangle, which is easier to do because I'm not attached to this other one anymore. So n is across from 30, just like before. N radical 3 now is across from 60, so that actually corresponds with x. If we find the value of n, we'll multiply it by root 3 to get x. And then finally, 2n is equivalent to this hypotenuse, this 5 radical 3. Since 2n equals 5 radical 3, dividing by 2 there gives me an n value of 5 root 3 over 2. And now if I want to find x, we know that x is the same as n radical 3. So that means we're going to have 5 radical 3 over 2 times radical 3. Well, root 3 times root 3 is just 3. So we've got 3 in the numerator times 5 is 15. And so that's 15 over 2.